Okay, so last thing in this section, we want to be able to evaluate compositions of these functions. And so hopefully you remember that if you compose a function with its inverse, they cancel each other out, you just get x for whatever was the input. And that is also the case with inverse trig functions as long as we verify the domain and the range. So we just have an extra step of double checking those things. So a couple of notes here. So here I have just the general rule about inverse functions. If I plug a function into its inverse, then I just get x. They cancel each other, they undo each other, I just get x. And that's true both ways. So this is like if you took the square root of x squared, you just get x. If you take the square root of x and you square it, you just get x. They undo each other because they're inverses. Okay, so here I have arctan inside of a tangent. Seems like they should just cancel each other. I should just get -5. That is the case as long as -5 is in the domain of arctangent. So what's the domain of arctangent? The domain for arctangent is all real numbers. So -5 is fine. And that's the answer. So in this case, because -5 is in the domain of arctangent, this tangent is going to cancel out whatever the arctangent does, and I'm just going to end up with -5. So is the same thing true with this arcsine of sine of 5 pi over 3? Are they going to cancel each other? Is the answer going to be 5 pi over 3? Something you could do if you're not sure, you can work these from the inside out. So if you can evaluate that inside function, if you can find sine of 5 pi over 3, then you can just take arcsine of whatever that is. Let's do it that way. Let's do that. If you're not doing it from the inside out, you would have to check and see if that input there inside of the sign falls between -pi over 2 to pi over 2. But if we evaluate sine of 5 pi over 3 first, we'll go to our unit circle. We'll find 5 pi over 3. Single right here. That gives us a sine value of -square root of 3 over 2. So let's put that in our problem. Okay, so now we evaluate the inside function first, and now it's a problem just like the first few that we did today. I need to find an angle whose sine value is -square root of 3 over 2. And you may say, well, we just found it from the angle. It's 5 pi over 3. But 5 pi over 3 is not between -pi over 2 and pi over 2. So that's the reason we can't use that. That's the reason they can't just cancel each other. So let's find out what that angle is. Did we do that? I think we did have this example before. We talked about how we can't use 5 pi over 3. We want to use that negative coterminal angle, which for this one is -pi over 2. Okay, so in part B, this is a good example of you can't just cross out arcsine and sine because they're inverses. 5 pi over 3 can't be the answer here because it's not in the range of arcsine. All right, here again, we could work from the inside out, or you can go straight to checking to see if the numbers are in range. So here, if I want to find cosine inverse of pi, I need to make sure that pi is in the domain of cosine inverse or arc cosine. And it is not. The domain of our cosine is -1, +1. And pi is 3.14 something. So it is bigger than 1. So this is not possible. And I'll make a little note here that this has to be between -1 and +1. And because it is not, we cannot evaluate this. So next, we'll look at a couple of examples where we have a composition of functions, but they're not the same. So maybe we have an arc cosine inside of a sine. And also if the inside function is not something that you can evaluate, it's not something that we have on the circle, and we'll see how we can solve that type of problem. All right, let's find tangent of arc cosine of 2 over 3. So looking at the inside function, to evaluate arc cosine of 2 over 3, I would check and see is 2 over 3 in the domain of arc cosine. So is it in between -1 and +1? And it is. However, it is not a number that shows up in the coordinates of my unit circle. So I'm not going to be able to find this there. So something else that we could do we could draw a triangle from this information. Okay, so a current cosine of 2/3 will give us an angle, so that's theta. Let's draw a picture. Okay, we're going to use a triangle, so let's make this a right triangle. So this angle theta, cosine value is 2/3. Cosine is adjacent over hypotenuse. So in this problem, that's 2/3. So let me label those on my triangle in relation to this theta. This would be the adjacent side down here. Hypotenuse is the long side of opposite the right angle, so that's 3. Now, ultimately, we want to find tangent of this angle, and tangent is opposite over tangent is opposite over adjacent. So we need to figure out this opposite side to be able to solve this. Okay, so we're going to use the Pythagorean theorem. We got a squared. We don't know b squared. That's got to equal c squared. So 4 plus b squared equals 9. Okay, and I'm trying to figure out b, so I'm solving for b. I need to, let's start by subtracting this 4. So b squared equals 5. Square root on both sides. That would mean that b has to equal the square root of 5. So that is this side over here, the opposite side. So now I've got all 3 sides of this triangle. I can evaluate tangent of this angle theta. So tangent theta is the square root of 5/2. And that's it, we've solved that. Okay, just one more of this same type. Okay, so I can solve this the same way as long as -3/5 is in the domain of arcsine. So it has to be between -1 and +1, and it is. So this is going to give me my angle theta, and I'm going to draw a triangle. So sine is opposite over hypotenuse. The hypotenuse is always positive, so that means that 3 has to be negative. And for sine to be negative, we're going to be in the 4th quadrant. So this is my angle theta. My 3 is negative. My hypotenuse is a +5. There's my right angle. Let me see, do I need to find that other side? We want cosine of this angle theta. And cosine of theta is the adjacent side over the hypotenuse. So we do have to solve to find the adjacent side. All right, so we've got a short side squared plus the missing side squared equals the hypotenuse squared. So that's 9 and 25. I'm solving for b, and you don't have to call it b, whatever you called it is fine. If you want to call it x, that works. So I gotta try to get this b by itself. I'm subtracting 9. So I have b squared equals 16. And then I'm square rooting. And the way that I have drawn this already makes it clear that this is going to be positive. This x coordinate is going to be positive. So I want the positive square root, which is just 4. So this is going to be 4 up here. And I can use that to find cosine of this angle. The adjacent side is 4, hypotenuse is 5. I'm going to double check. Sine is negative. Cosine is positive. And my answer should still be something that's between -1 and +1.